In this module, we will explore the use of pointers in C to effectively manipulate strings. Pointers are a fundamental concept in C, and mastering them is essential for writing efficient and powerful code. Here, we will uncover how pointers can be used to work with strings and character arrays. Let's delve into how strings are represented in the memory. In C, strings are essentially arrays of characters, and they are always terminated by a null character, which is denoted as \0. Understanding this null termination is crucial because it tells the C compiler where the string ends. A string pointer, as the name suggests, is a pointer that points to the first character of the string. Now let's consider the memory layout of the word hello. Each character occupies a memory cell, with the addresses indicated above each cell. The string variable, string, holds the address of the first character, h, which is located at memory address 10,000. The arrow visually represents that string points to this address. Let's consider the different methods of declaring a string. The first method involves using a string literal, such as hello. However, it's important to note that this creates a read-only string. The second method involves using a character array with a specified size to accommodate all the characters in the string, including the null terminator, \0. The third method involves initializing each character of the string individually, with the last element being the null terminator. The fourth method involves declaring an empty array, and then using the string copy function to assign a value to it later on. Let us discuss how we can traverse through a string using pointers. The first example is a function called printString, which takes a character pointer as an argument. Inside the function, a while loop continues until the character pointed to by string is not equal to the null terminator. Within the loop, the character pointed to by string is printed using printf, and then the string pointer is increment to move to the next character. The second example is a function called stringLength, which also takes a character pointer as an argument. Inside the function, a variable length is initialized to 0. Then, a while loop continues until the character pointed to by string is not the null terminator. Within the loop, the length variable is increment, and the string pointer is increment to move to the next character. Finally, the function returns the calculated length. Here are some key points to remember when using pointer traversal. Pointers can be increment to move to the next memory location. String ++ advances the pointer to the next character. An asterisk, string, dereferences the pointer to access the character. The null character, \0, marks the end of the string. Pointer traversal is more efficient than array indexing. So remember to be careful not to increment beyond the string's end. Now let's see how to copy a string from one memory location to another using pointers. A custom function called stringCopy is implemented to perform this task. It takes a destination and a source character pointer as arguments. The function then iterates through the source string until it encounters the null terminator. In each iteration, it copies the character from the source to the destination, and both the source and destination pointers are increment to move to the next character. Finally, after copying all characters, a null terminator is added to the end of the destination string. In the usage example, a source character array is initialized with the string hello, and a destination character array is declared with the size of 10. The string copy function is then called to copy the source string to the destination string. Let's consider how this looks in memory. In the source string, each character of hello is stored in consecutive memory locations starting from address 10,000, with the string pointer pointing to the first character at address 10,000. After copying, the destination string contains the same characters as the source string, but stored in different memory locations starting from address 20,000. The destination pointer now points to the memory location after the last character of the copied string. Here are the operation steps. First, copy each character from the source to the destination. Second, increment both pointers after each copy. Third, add the null terminator to mark the end of the string. Let us dive into comparing strings using pointers. Let us consider a custom function called stringCompare. which takes two constant character pointers as arguments. The function then iterates through both strings until it reaches the end of either string. Within the loop, if the characters at the current positions in both strings are not equal, the function returns the difference between their ASCII values. Otherwise, both pointers are increment to move to the next character. Finally, the function returns the difference between the characters at the end of the strings. In the usage example, two character pointers are initialized with the string apple, and the string compare function is called to compare them. If the result is 0, it indicates that the strings are equal. Here's a list of standard string functions available in C, along with their descriptions. String compare compares two strings, string copy copies a string to another, string concatenate concatenates one string to the end of another, string length returns the length of a given string, string character finds the first occurrence of a character in a string, and string string finds the first occurrence of a substring within a string. Remember that all these standard functions use pointer manipulation internally for efficient string operations. And you need to include string.h to use them. Let us learn about some more advanced string manipulation techniques. String tokenization is the process of breaking a string into smaller parts, called tokens, based on a specified delimiter. A function called tokenizedString is implemented to demonstrate this. It uses the string token function to split the input string based on delimiters such as comma, space, dot, and hyphen. In the example usage, a character array is initialized with the string hello world. This is C. The tokenizedString function is then called to tokenize this string, and each token is printed on a new line. Here are some best practices and common pitfalls to keep in mind. Always check for null before dereferencing string pointers. Ensure destination buffers are large enough for string operations. Use the constant qualifier for string parameters that shouldn't be modified. String literals are immutable, so don't try to modify them. String token modifies the original string, so use a copy if needed. Remember to null terminate strings after manual manipulation. In summary, pointers provide powerful and efficient ways to manipulate strings in C. Understanding the relationship between pointers and strings is essential for effective C programming. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.